Hello and welcome to this video on graphing an equation using the point plotting method. So in this video I'm going to go over several examples of equations in two variables, and they'll be x and y in this video. They don't have to be, but in this video they are. And we'll be drawing a graph of the equations. Now whenever they say to graph something, right, that just means draw a picture of the solutions to the equation, right? And the solution is, values I can replace the letters with, the variables with, to make a true statement. And these are going to be equations with an x value, x and a y, so my solutions will be ordered pairs, a pair with an x value and a y value. And we will plot points representing those ordered pairs on the xy coordinate plane, and once we have enough, hopefully we can see a pattern and kind of fill in the rest. And hopefully you'll see what I mean when I go through several examples. All right, so the first of these, some graph paper here. If you don't have graph paper, that's fine. You can just make your set of axes on a piece of paper and try to eyeball it by hand. Maybe use a ruler for a straight edge. Here I'm asked to graph the equation using the point plotting method. Alright, so as I mentioned, there's an equation y equals 3 times x plus 1, and what we're doing is graphing, drawing a picture of all the solutions to this equation. And a solution to an equation with multiple variables is going to be, there are two variables, so it's going to be one pair of numbers will be one solution, represent one point on the plane. Alright, so what I'm going to do here is notice that this equation is solved for y. Right, you see how y is all alone? It's solved for y, and that'll tell me that, I think an easy way to find a solution, or find solutions to this equation, would be to substitute values for the x variable. Right? I'm going to plug in values for x and see what y is equal to, since y is already solved for. So in this one that's solved for y, I'm going to plug in values for x when finding solutions. Alright, so on a separate sheet here, I'm going to make my graph on this page, lay over this separate piece of paper. I'm going to make a table. Alright, a table that'll help me determine ordered pairs, help me determine solutions to this equation. Alright, now I mentioned I'm going to plug in values for x. So down one column here, or if you want to make them rows, that's fine, but so down one column, plug in values for x. We'll just replace it with anything, again, as long as you don't divide by 0, which isn't going to be happening here, right? There's no value of x that'll make a denominator 0. Then down the second column, my calculation, right, here's the equation again, y equals 3x plus 1. We're going to be solving for y. And then in the third column, if you want to add it, it's fine. I'll just do it to make it easy to see the solution. The solution to the equation, the ordered pair, where the x value is first, comma, and the y value of the solution is second, and surrounded by parentheses. And this represents points on the coordinate plane, which you'll see me plot when I'm done. All right, so what do I plug in for x? Okay, I'm trying to plug in enough. I'm trying to plug in enough values so I get enough solutions to see a pattern forming. Now those of you out there, you might be seeing this, and you might recognize this as a linear equation. Right? The graph is going to be a straight line, so you only need to plot 2 points to graph a straight line. But let's say for some reason I didn't see that right away, and I like to start off with like 5 points. If there's a graph I'm unfamiliar with, or at least when you start it off and you're the more you practice this stuff, the more familiar with the equation types you'll get, and you'll probably have to plot less and less to know where the graph is going. But right now I'm going to plot 5, and I like to have it centered around, the middle of the real number line. There's going to be an x-axis that's horizontal and a y-axis that's vertical, 2 number lines, one representing each variable. I like to center around the middle, where 0 is on the x-axis. So I'll plug in these 5 values, say -2 for x, then -1, then 0, then 1, then +2. Okay, that's 5 values centered at 0. And let's see what kind of ordered pairs this gives me. All right, so now into the equation. I replace x with -2. The value of y would be 3 times -2 plus 1, and then you simplify order of operations, you multiply before adding. -6, right? 3 times -2 plus 1 is -5. So the point I'm plotting, the ordered pair I'm plotting, the solution to this equation is an x value of -2, comma, and a y value of -5. All right. And I'll get to plotting these points in a minute after I'm done with the table here. -1 for x. Same thing. I go to the equation y equals 3 times -1 and then plus 1, right? Replacing x with -1. 3 times -1, that's nothing. Sorry about that. 3 times -1 is -3, plus 1 would be -2. All right. So the ordered pair, the solution to this equation, is -1 for the x value, -2 for the y value, and I'd be plotting this point. And again, you'll see me plot these in a minute. 0. Again, going back to the equation, y equals, replace x with 0. 3 times 0 plus 1. That's just 1, right? 3 times 0 is 0, plus 1 is 1. So the ordered pair that I'm plotting, the solution to this equation is, the 0 for the x value, +1 for the y value, so 0, 1. Plugging in 1, y equals 3 times 1 plus 1, that would be 4, right? 3 plus 1. So the point I'm plotting has an x-coordinate of 1, a y-coordinate of 4. And finally, again, we can plot more points if you want. Plug in all sorts of, you don't have to plug in whole numbers either. You can plug in fractions. You can plug in, crazy decimals if you wanted to. It's just integers. These integers are nice, easy numbers to pop in. So 3 times 2 plus 1, that's 6 plus 1, or 7. So the point I'm plotting has an x-coordinate of 2 and a y-coordinate of 7. Alright, so now I get to the actual plotting of these things. Alright, so I'm going to take this away for a second. We'll come back to them. And on my graph paper here, I'm going to make some axes. Alright, so it's nice right here. Let's say this horizontal line going along this here, this is the number line representing the x-axis. Alright. And then perpendicular to that, this represents possible values of x. Perpendicular to that, say here, going vertically, straight up and down, is another number line that represents all possible values of the y variable, right? The y-axis. Where they meet is called the origin, and that's where the value of x is 0 and the value of y is 0. And if you're unfamiliar with this, let me just do a quick recap. You have 0 in the middle for the x-axis, positive numbers to the right, negative numbers to the left. And then for the y-axis, you have 0 in the middle on the y-axis, and then positive numbers going up, negative numbers going down. So it's almost like the x-axis rotated counterclockwise 90 degrees. All right. So now for the point plotting. All right. Here are my points. All right. So there's the axes. There's the equation. Here are the points we got in my table. Now, how do you plot a point? Is so if I want to plot this point here, this is a solution to that equation. Plugging in -2 for x and -5 for y makes a true statement. You'd get -5 equals -5, right? And all we're doing is drawing a picture on this coordinate plane of that point. So you mark off, where's -2 on the x-axis. Now each of these notches, right? In my graph paper here, I'm going to make little notches. But each square, You can have each square represent 1 unit. You can have each square represent 2 units. Every one represent 3 units. Just be consistent though. If you make each square represent 2 units, make sure you stick to that. And vertically, if I make each square in the y direction represent 3 units, stick to that. Just be consistent. I'm going to make it easy and just have every square represent 1 unit. So -2 on the x-axis would be right there, right? Zero's in the middle. There's -1, -2, 2 squares to the left. And then where's -5 on the y-axis? Now I'm going up and down. Zero's in the middle where the two axes cross, and then again I'm going to have each square represent just 1 unit. So there's -1, -2, -3, -4, there's -5 down here. And then the location that I'm marking that I'm going to put a point at is the only location that's in line with both of these numbers. So that's in line with -2 on the x-axis and in line with -5 on the y-axis. So that's this point right here. All right, and if you would like to label that, maybe put the ordered pair next to it, that's fine by me. All right, that's great. Okay, so there's one point, a picture of one solution to this equation. -2 for x, -5 for y. And let me plot the other ones. So -1 for x, -2 for y. So there's -1 for x, and then -2 for y on the y-axis, and then that's this point right here. That's in line with both of those. So there's a picture of just 2 solutions to this equation. The next one, 0 for x, 1 for y. 0 on the x-axis is right in the middle. 1 for y is 1 unit up, and the only point that's in line with both of those is actually on the y-axis. That point right there. So now I have a picture of 3 solutions, and let's get all 5. 1 for x, and then 4 for y. 1 for x, 4 for y, that's this point here. Then 2 for x, 7 for y, and 2 on the x-axis, 7 on the y-axis. That's this point here. Alright, great. I've just drawn a picture, a graph, of 5 of the solutions to this equation. Alright, but you may know that I didn't have to plug in just these 5 values. There are infinitely many possibilities. You can plug in any number as long as you don't divide by 0 or take even roots of negative numbers. We're dealing with real numbers here, not imaginaries. Or logarithms, if you ever come across those. You'll see you can't take logarithms of non-positive numbers. Anyway, but I can plug in anything for x I want. So there are I could make this table go forever, right? There are infinitely many solutions to this equation. So this is not the end, right? These 5. What I'm trying to do, what this point plotting method is I'm plotting enough solutions to where I start seeing a pattern. Alright, and perhaps after looking at these 5 points, these 5 solutions, you notice, hey, looks like all 5 of these solutions are falling on a nice straight line. So then you fill in the rest of what's called, the complete graph, where you like, hey, the rest of the infinitely many solutions most likely fall on this line, right, where I'm drawing a line through all these solutions and going this way as well, right, because again I can pick x to be anything I want because you're never going to divide by 0 here, right? And to indicate that I'm going to be doing this forever, going forever in that direction, I'll put a little arrow, and it's going forever in that direction, I'm going to put a little arrow. And there's what's called the complete graph of this equation, y equals 3x plus 1. Yes, I only plotted 5 solutions, but I have, based on the pattern that those 5 solutions form, I've drawn in where I think the rest of the solutions are, right? The rest of the infinitely many solutions. Great. Again, test it out. Try some other points. If I were to plug in a half, right? If you plugged in a half or a third, if I plugged in 1/3 for x, you'd get 2 for y. 1/3, 2, right? You see that there is a point there at 1/3 of a unit, and then 2 units up. It looks like there's a point there. and it would work out for any x value you picked. You should find a point on this line I just drew. Great. And that's the goal, right? Plot enough points to where you see a pattern. Now that last example, right? This first example I just put, I had an equation where y, one of the variables was solved for, so I plugged in for the other variable. It made it a lot easier. There are plenty of equations you see where not one of the equations is solved for. All right, so here's one here. 2x plus 3y equals 8, and I'm doing the same thing. I'm asked to graph this equation, right? Find a bunch of solutions, make a graph, picture the solutions with this point plotting method. This one is not solved for any particular variable. Now, this is an equation where, yes, it's not solved for a variable. There's not a single variable alone on one side, but it would be very easy to solve for a variable. You don't have to, right? If I wanted to find a solution, I could let x be, say, 2 if I wanted. And if x were 2, if x were 2, then you'd have 2 times 2 plus 3y equals 8. And then this would be 4, and I'd subtract 4. Right? 4 plus 3y equals 8. I'd subtract 4 and then get 3y equals 4, and then divide by 3. Y would be 4/3. And the solution I'm getting from there is ordered pair x value 2, comma, y value 4/3, or 1 1/3. And then, then I'd plot that point. So I could pick a value for x and easily find a solution, or I could pick a value for y. And then, before I get too crazy on this paper, let me go on this page here. If I let y be something, right, let's say I let y be, I don't know, 5. It doesn't matter, right? There's nothing that's going to make me, there's no denominators that are going to be 0 here, so I can plug in anything I want for y. Then you'd have 2 times x plus 3 times 5, replacing y with 5, equals 8, and then that's 2x plus 15, right, equals 8, and then I would subtract 15, giving me 2x equals -7, dividing by 2, x equals -7 halves. And then so the solution I'm getting from this, the point I would be plotting, would be the ordered pair where the x coordinate is -7 halves and the y coordinate is the one I chose there, 5. So you see, I get solutions either way, all right, whether I pick x values or pick y values, and I could have done that in the last example too. It's just in the last example it was much easier to pick for x because y was already solved for. All right, so I actually prefer doing that in a lot of cases, where if I'm given an equation and I'm asked to graph it, if it's pretty easy to solve for one of the variables, I'll just do that. Like this one here. Now, yes, granted, there are going to be equations in the future where it's going to be difficult, if not impossible, to get one of the variables alone. And in those cases, then I would just keep the equation the way it is, and pick a value for one variable, solve for the other. But for right now, I'd say if it's simple, if you can see how to solve for one variable, I would say if you can solve for one of the variables, I'd recommend it. I'd recommend it. You don't have to, but I would recommend it. All right. So here's the equation I was given: 2x plus 3y equals 8. And I'm going to solve this like in the first equation for y here. All right. Both x and y are to the first power, so solving for each of them would be just as difficult. So I'm going to solve for y. All right. So I'll subtract 2x, giving me 3y equals, now when I subtract 2x, that'll give me -2x on the right side, and then you saw the positive 8. And then I'm going to divide everything by 3, right? You divide this term by 3 and this whole side by 3, which will be both terms, right? So you'll have y equals, and then -2x plus 8, all divided by 3. You can leave it like that if you want, or -2/3 x, right? Dividing this term by 3, -2/3 x plus 8/3. All right, and that's fine too. Okay, so here we go. I'm gonna make a table. Now I have solved for y. All right, I've solved for y. So like in the first example, it would be a lot easier to find points, find solutions if I plug in for values for x. Okay. So I'm going to make a table. Here's values of x, and then the equation again, y equals negative 2/3 times x plus 8/3, and then a third column with the solutions, the points I'm going to plot. Now I know I already have two solutions. In fact, I'll plot these later if you want. I'll plot them as well as these ones I'm going to plot here. So as with the previous example, I don't know how many I want to plug in. I'll plug in 5 to start and centered around 0. So the same values, the -2, -1, 0, 1, and 2. All right, and let's just see what happens, and we'll go from there. So this one, y equals now negative 2/3 times -2 plus 8/3. Right? This would be 4/3, right? Negative times negative. That'd be positive 4/3 plus 8/3. That'd be 12/3. All right, and 12 divided by 3 is 4. So the ordered pair I'd be applying there has an x-coordinate of -2, a y-coordinate of positive 4. Very nice. When x is -1, y equals negative 2/3 times -1, and then plus 8/3. That's positive 2/3 plus 8/3. That'd be 10/3. So not as nice, but I can still eyeball it. All right, I'm still going to just kind of eyeball the point when I go plotting it on the coordinate plane. So the solution I'm going to plot there has an x-coordinate of -1 and a y-coordinate of 10/3, right, which is 3 1/3, right? So a little bit more than 3. When x is 0, y equals -2/3 times 0 plus 8/3. So again, that says 0, this first 0/3, and then 0 plus 8/3 is 8/3. So this has x-coordinate 0, y-coordinate 8/3, which is 2 2/3. That's a little less than 3. When x is 1, -2/3 times 1 plus 8/3. That's -2/3 plus 8/3. -2 plus 8, the numerator would be 6/3. Well, 6/3, 6 divided by 3 is just 2. So this will be a nice easy one to plot, 1, 2. And then we already did this one. All right, -2/3 times 2. I already have the solution with an x-coordinate of 2 up here. The result should be 4/3, and you'll see that here. Then plus 8/3, right? -2/3 times 2 would be -4/3, and -4/3 plus 8/3 would indeed be positive 4/3. All right, so 2 for the x, 4/3 for the y. And again, you can go forever. Keep plotting points. Again, I'm just going to stick to these 5, and I might even throw in this 6th one here where the x-coordinate was -7/2 and the y-coordinate was 5 that we found earlier by plugging in a y value. All right, so I'm going to pull this off, and we'll make our coordinate plane on the graph paper. All right, so here's the horizontal x-axis, right, representing values of x, and then somewhere in the middle here, the vertical y-axis, right, representing values of the y variable. Okay. I like to label them, right, so I know which is which. All right, now I'll bring in that table. All right, there were my 5 points right here, and I will plot them. All right, so the first of those, -2 for the x-coordinate, and again I'm going to have every square be just one unit. So 2 to the left on the x-axis, there's -2 on the x, and then positive 4 for the y. And so the point we're talking about is this point right here. That's in line with both of them. All right, so there's a picture of that one solution. All right, then negative 1 and 10/3, right? So negative 1 for x. Now 10/3, that's 1, that's 2, that's 3. 10/3 is, 3 and 1/3. So it's 3 and then a third of the way to 4. So let's say, I'm going to eyeball this. Say this is 10/3 here. Sorry about the clutter. That's the tininess of that. But a third of the way between 3 and 4. So negative 1 and then 10/3. So maybe around there. There's a picture of another solution. All right. Then 0 8/3. Right. So 0, we're in the middle of the x-axis here. 8/3 is 2 and 2/3. So 2 and then 2/3 of the way. There's 8/3. 2/3 of the way from 2 to 3. So there we go. This point right here, that's in line. It's on the y-axis, right? Because it has an x-coordinate of 0. Again, just eyeballing it. 1, 2. That's an easy one. 1 for the x, 2 for the y. We're talking this point right here. And then my final point, 2 4/3, right? 2 for the x, and then 4/3, right? 4/3 is 1 and 1/3, so 1, and then about a third of the way between 1 and 2, right? So maybe about here, right? 4/3. Again, just kind of eyeballing it. This isn't precise, but look again. Notice again that all of these points seem to be falling on a straight line, and you're going to notice that with equations like this, where there's no variables in denominators, and my two variables, my x and my y, both are to the first powers in each of their terms. Right? This is another one of those linear equations. So the graph is going to be a straight line, and I'm noticing that these 5 points again fall on a straight line. And in fact, let me plot this 6th point that we found as well. So x coordinate negative 7/2. Now that's negative 3.5. So negative 3, here's negative 4. So negative 7/2 is halfway between negative 3 and negative 4. There's negative 7/2. And then 5 for the output, 5 for the y coordinate. So negative 7/2 and 5. Alright, but again, look at even that point I popped in. Still looks like it falls on this same line that all of these are. Right? So let me fill in the rest. Right? There's no way I can plot all infinitely many solutions to this. So we plot enough to where we see a pattern, and then I fill in the rest. Right? Draw what's called the complete graph here. Just a straight line going through all these points. And going that way forever, and there we have it. Okay. Wonderful. Right. And if you want to keep going, plug in 3, 4, 5, plug in 3.5, plug in 5/3, plug in 7/8, plug in pi. You plug in whatever you want. All right, as long as it's a real number and you're never dividing by 0 or something. That's not allowed with real numbers. Great. So there's the graph of that equation through this point plotting method. Alright, so the past two examples have been what they call linear equations, and you may have noticed that the variables x and y were both raised to the first power, had an exponent of 1. But that's not always the case, right? You know that. Here's an equation where that's not the case, right? Say I was asked to again graph this equation by the point plotting method. Y equals x to the second power, x squared plus 3. That power of 2 on the x indicates to me that this is not going to be a nice line, a nice linear equation. All right, and let's check it out. Now, as before, I'm going to make the table on a separate page here. This is again solved for y right away. Because it's solved for y, I think it would be easy to plug in values for x to find points. Alright, because then we can very quickly determine what y is. Alright, so on this next page, here's a table. I'm going to have one column where I plug in for x, values for x here. Then this column will help me, my calculation, how I'm going to determine the y. I'll just write the equation again, y equals x squared plus 3. And then down the third column, I'll list what the point is, right? What the solution is that I'll be graphing, the ordered pair. All right, and as before, right, I don't know exactly where to start, so I'm going to start with, just values centered around 0. We'll plot 5 points. All right, so again, I'll plug in -2, -1, 0, 1, and 2. And again, you don't have to start the way I'm starting. You can plug in whatever numbers you wish, as long as you're not dividing by 0 or doing any other things that are improper with real numbers, which we'll get to in later videos. Okay, so the first one, y equals. Now remember, when you replace something, I haven't really mentioned this, but whenever I replace a variable, replace an expression with another expression, especially if it's a negative, I like to put parentheses around it. You may have noticed I've been doing that, right? So instead of x squared, it's -2 squared and then plus 3. Now -2 squared, remember, is negative. That means -2 times -2, so that's +4. And then plus 3 is +7. So I have the ordered pair, -2 for the x coordinate, +7 for the y coordinate. There's a solution to that equation, makes that true. The next one, y equals, and then again replacing x with -1. So instead of x squared, I have -1 squared, which means -1 times -1, which would be +1, and then the plus 3 makes this +4. So I've got -1, +4 for the ordered pair, that solution that I'm going to plot. When y equals 0, you got 0 squared and then plus 3. Well, that says 0 plus 3, or 3. So the ordered pair has x coordinate 0, y coordinate 3. Y equals 1 squared plus 3. Well, 1 squared is just 1. 1 times 1, and then plus 3 is 4. So 1 for x coordinate, 4 for y coordinate. And then finally 2 squared plus 3. 2 times 2 is 4, plus 3 is 7. So 2 for the x coordinate, 7 for the y coordinate. Again, I'll plot these 5 points, and maybe we'll see something, maybe we won't. And if we don't, I'll plot some more. Maybe even plug in some fractions, something between these, like a half or 2.5 or a 1.5 or a third or something. Let's just see what happens. All right, so here are the points I'm going to plot, and I'll put up the coordinate plane over here. Let's make our, here's our x-axis, horizontal x-axis, right? Number line representing possible values of the x variable. And somewhere in here in the middle, something perpendicular going vertically. There's the y-axis, another number line. All right. All right. And let me plot some of these solutions. All right. And as before, as with the other ones, I'm just going to have it be so that every square, every notch is just one unit. So -2, 7. -2 for the x, -2 on the x-axis, 7, 1, 2, 3, 4, 5, 6, 7 on the y-axis. So the point in line with those is this point right here. All right, so there's that solution. All right, this one here. And then -1, 4 is another solution. -1 for x, so -1 on the x-axis, 4 on the y-axis. There's another one. And you couldn't stop right now, because if you just stopped right now, right, oh, I got 2 solutions, it looks like you could draw a line through those. But again, I'm telling you, with the power of 2 on the x there, you're not going to have a line. Trust me. We'll see that coming up now. When the ordered pair 0, 3 is plotted, 0 on the x, I'm in the middle there, 3 on the y, that's this point on the y-axis, 0, 3, right there. And you see right now, if I drew a straight line through these two, it would not hit this point. If I drew a straight line through these two, it wouldn't hit that point. So these points do not form a straight line. The order pair 1, 4, right? So 1 for the x, a +1 for the x, +4 for the y. That's this point here. And then 2, 7, right? 2 for the x coordinate, 7 for the y. That's this point up here. So definitely not a straight line. It looks more to me like it's forming kind of a U shape. And again, you can plot other points. If I plugged in 3, you'd have 12, right? 3 squared plus 3, 9 plus 3 is 12. 8, 9, 10, 11, 12. Okay. So I might as well plot that. There's 3, 12 up there. Same thing for negative 3. If I plugged in negative 3 for x, negative 3 squared is positive 9 plus 3 is 12. So negative 3, 12, there's another point, another solution. So it's definitely looking like it's, doing this kind of U shape. All right, and I'll draw that in. So it looks to me as though the solutions are forming this kind of a shape right here. And hopefully it makes sense too that if I increase the value of x, if I go 4 squared, 5 squared, 6 squared, plus 3, that's just going to make the outputs, the y coordinates, larger and larger, and the same on both sides. So it looks like it's going this way, up forever, this way, forever. And we get this thing called a parabola, right? This U shape for the y, when one of the variables is squared and the other one is not, x squared, y to the first, you're going to get a graph that has a shape called a parabola or a parabolic shape. Let me write that off to the side here. And it's not, I'll just say it's not pointy at the bottom. This is nice and smooth down here. So just don't make this super pointy if you're graphing a parabola. Again, an equation where one variable is squared and the other variable is not. Okay. And great, so there's an example of equation that the graph is not linear, and I did it again with this point plotting method where I just plugged in a bunch of values, got a bunch of solutions, I plotted those solutions, and hopefully through the plotting of a bunch of solutions you see a pattern, you see how the rest of it might look, and then you fill it in, right? You're really kind of just guessing, but it's a very, very educated guess. Right, and it's very good. It's pretty good. And if you want to plot other ones, be my guest. Plug in a half, plug in 1.5, 2, plug in fractions, get other points. You'll see you're going to be getting points along this like U shape, this parabola shape. All right, so I just got a couple more for you, and you'll see that these are also going to be these parabola shapes. All right, so the next one I've got is similar to the last one where one of the variables is squared and the other one is not, but the variables are switched. See, this one I'm asking the graph x equals y squared plus 2. So the y is squared and the x is to the first power. Now it's still that scenario where one variable is squared and the other one's not, so the graph will be this parabola shape, but it's not going to open in the same direction as the previous example. And another thing to point out is that this equation now, right, all my previous equations, all the previous examples in this video, I have solved for y, right? I got y alone. This one is solved for x. And since it's solved for x, I think it would be easier to find solutions in this case by plugging in for y instead. I would rather plug in y values when I make my table. So speaking of which, here's my next page. I'm gonna make a table where down one column I'm gonna put values of y. Right, so you got to pay attention here. This is an x. Put values of y. The second coordinate in the ordered pairs down this column, and then the second column is going to be values of x, where I'm going to write the equation out. How are we calculating that value of x? We're taking the y value and squaring it and then adding 2. And then in the third column, the ordered pair with the x coordinate first, y coordinate second, the point I'm going to be plotting. All right, the solution to the equation. All right. So as before, as in the past several examples, right, I don't know exactly where to start here, so what I'm going to do is start around the middle. Now this is for the y-axis, right, the vertical one. I'm plugging in y values. And again, I'll start so that I have some values that are centered around 0 just to see where that takes me. So the same 5 values again, negative 2 for y, negative 1 for y, 0 for y, 1 for y, 2 for y. And you do not have to use these 5. Right? I know I've used these 5 in every example. You can use whatever you want, right? Just so long as you're not dividing by 0 and stuff like that. Alright, so when y is -2, the value of x would be, and I'm replacing y with -2, so -2 squared plus 2. Well, remember that's -2 times -2 is +4, plus 2 would be +6. So the ordered pair, now be careful, the ordered pair wouldn't be -2 comma 6, right? This was the y coordinate and this was the x coordinate that I was solving for here. So the x coordinate is 6 and the y coordinate, what I plugged in, is the -2. All right, so I'm going to be plotting that ordered pair. 6, -2. Next one, when y is -1, x equals -1 squared plus 2, that would be 3. Sorry about the clutter there. That would be +1 plus 2 is 3. And again, pay attention. 3 is the x coordinate, and -1 is that I plugged in is the y coordinate. And when y is 0, you have 0 squared plus 2, which is just 2. And again, 2 is the x coordinate of the point, 0 is the y coordinate of the point that I'm going to plot. When y is 1, 1 squared plus 2 is 3. So 3 is the x coordinate, 1 is the y coordinate. And when y is 2, 2 squared plus 2 is 6. 6 is the x coordinate, 2 is the y coordinate. All right, so I'm going to plot these 5 points and see where that takes us. And if I want to plot more, I will. All right, like in the last one, I plotted 2 other points, right? I plotted 7 points total before I decided, hey, it looks like it is going in that U shape, that parabola shape. All right, so I'll keep these points off to the side here, and let's make our graph. Right? I'll make the coordinate plane. And let's say this is the x-axis here. Horizontal, and then somewhere in the middle here, this is the y-axis. Okay, and let's plot some of these solutions, make a graph. First one, 6 for x, -2 for y. So 6 for the x coordinate, so 6 on the x-axis, -2 for y. Right? So that's this point right here. That's just one solution to this equation, makes this true. 3, -1, right? 3 for the x, -1 for the y. That would be this point here that's in line with both of those. There's a picture of another solution. 2 for x, 0 for y, 2, 0. So 2 for x, and since y is 0, I'm not moving anywhere. This is it. I'm in line with the middle of the y-axis. So it's got a y coordinate of 0. Your point is on the x-axis. So there's 2, 0. And notice it's definitely not a straight line. This graph, 3, 1, 3 for x, +1 for y. There's that point. So definitely not a straight line now. All right, you can definitely see that now. 6 for x, 2 for y. All right, 6 on the x-axis, 2 on the y-axis. That's this point here. And can you see the parabola shape? All right, it's just like my previous example, but this time it's a parabola that's going to be opening to the right. And again, if you want to plot other values, plug in other values. Now remember, I was plugging in for y, right? Now say I plugged in 3 for y, right? Plug in 3 for y. 3x would be 3 squared, or 9, plus 2 is 11. So 7, 8, 9, 10. You'd have 11 for the x, 3 for the y, and that'd be that point out there. And if you plugged in -3 for y, you'd also get 11 for x, right? -3 squared plus 2, and that'd be that point down there, 11 for x, -3 for y. And hopefully you're seeing this parabola shape, and going that way forever. And again, it's not pointy, right? They're not pointy at the vertex here. It's more curvy. And let me fill this in a little more, make it a little thicker. Going that way forever. And then the same thing down here. All right, continuing on down here. This is pretty ugly. Sorry. And that. Let me sketch it a little more. All right, so there you go. All right, there, and again, little arrows to indicate we're going that way forever, that way forever. But again, I have this parabola shape where the parabola is, opening to the right. And I found it by this, again, this point plotting method. You plot enough points to where you see a pattern, and you basically are filling in that pattern, saying, I believe, based on the 7 solutions I plotted here, the 7 points I plotted, I believe the rest of the solutions of this equation will follow that same pattern. And you fill that in. All right, so I've got just one more example here. The last couple parabolas I've drawn, the last couple examples, the bottom of the shape, right, what's called the vertex of the parabola, that point in the middle where it turns, was on one of the axes, right? For this one, it was on the x-axis, and for my example before that, right, it was on the y-axis, this point where the graph turns. But that's not always going to happen either. All right, my last example I've got for you is another one where there's going to be a parabola shape, right? Because you have one variable being squared. You have this quantity with y being squared, so the y is being squared, but the x isn't. So again, you're going to have a parabola shape. And let's see how this one goes after plotting a bunch of points. All right, so I have x equals now the quantity y minus 1, and that's being squared. Right? So I have the same as the previous example where the equation is solved for x, and as I said earlier, if you can solve your equation for one of the variables when graphing, I'd recommend doing that. Right? It'll just make it easier. You'll know, what variable would be easier to plug in for, and all that. But only if you can, though. If it's some crazy equation like x squared plus 3x plus y cubed plus 8x over y equals 7 or something, if it's some crazy equation where solving for y would be difficult or solving for x would be difficult, I wouldn't recommend wasting your time. Right? Just plug in a value for x, solve for y, plug in a value for y, solve for x to get some points that way. But when it is able to be solved for, I would recommend it. Alright, so here I have x equals y minus 1, the whole thing, that quantity squared, and I'm going to make a table. Now, as I mentioned, it's solved for x, so I believe it would be easier to plug in for y and then get the x coordinate, right, because it's already solved for. So in my table, the first column, it's going to be y coordinates, values of y I'm plugging in, and then the second column is how I'm going to calculate x, right, by just writing the equation again, x equals y minus 1 squared, and we'll get our x coordinate. And then the third column, the point that we're going to plot, right, with the x coordinate first, the y coordinate second. So whatever you get here is the x coordinate, right? Whatever you get over here, whatever you plug in here is the y coordinate, right? All right, and as always, I don't, just like with the past 4 examples that I've done in this video, I'm just going to plug in y values that are around 0. All right, from -2 to 2 again. You do not have to do what I'm doing. You can plug in whatever numbers you want. I like to plug in, at least 5 when I'm, trying to teach this. Again, with more experience and recognizing what kind of an equation you have, you'll need to plug in less, if you know what it's going to look like ahead of time. But I'm plugging in 5, and let's see what happens. So the first one, x equals, now it's already in parentheses here, so I've got -2 minus 1. I guess I could technically do the -2 in parentheses, but I'm replacing y with -2, and then that's being squared. Now -2 minus 1 is -3, and then -3 is being squared. -3 times -3 is +9. Alright, so that's 9 for the x coordinate. Be careful, right? Don't put -2 comma 9. This is the x coordinate that we're finding here. So 9 for the x, -2 for the y. That's the point I'm plotting. All right. When y is -1, x equals -1 minus 1 squared. -1 minus 1 is -2. -2 squared is +4. So positive 4 for the x and negative 1 was the y I plugged in. That's the point I'm going to plot. When y is 0, x equals, 0 minus 1, then all of that squared. Well, 0 minus 1 is negative 1. Negative 1 squared is positive 1. So I got 1 for the x coordinate, 0 for the y coordinate. When y is 1, you get 1 minus 1 squared. Well, 1 minus 1 is 0. 0 squared is 0. So I got 0 for x, 1 for y. All right, 0 for x, 1 for y. And when y is 2, 2 minus 1, that quantity squared. 2 minus 1 is 1. 1 squared is 1. So I get 1 for x, 2 for y. 1 for x, 2 for y. Great. So I'm going to plot these 5 points, these 5 solutions on my coordinate plane. And if I need to, I'll plot some more. Right? 5 isn't the limit. Right? You've seen me do 7 points in the past 2 examples. So I can see the pattern for sure. Alright, so again I'm going to do the x-axis, some horizontal number line here, x-axis, and then some vertical somewhere in here. So here's the y-axis, right? Great. And again, I'm going to have there will be times in the future in other videos where, every notch, every square I'm going to have be a different number of units. But again, for all the examples, I'm just staying consistent, and every single square is going to represent 1 unit. Alright, so the first point I'm plotting here is 9 for x, negative 2 for y. Alright, so 3, 4, 5, 6, 7, 8, 9 for the x coordinate. Negative 2 for the y coordinate, so I got a negative 2 on the y-axis, right, 2 down from the middle. There's the point in line with both of them. There's the point 9, negative 2. There's one solution. 4 for x, negative 1 for y. 1, 2, 3, 4 for the x coordinate, negative 1 for the y coordinate. That's this point right here. Great. 1 for x, 0 for y, the third solution here. So 1 for x, 0 for y, so I'm on the x-axis here. There's 1, 0. Then 0 for x, 1 for y. Right? 0 for x, 1 for y. That's this point on the y-axis. Great. Definitely not a straight line now. Hopefully you're seeing that. And then 1 for x, 2 for y. 1 for x, 2 for y. That's this point here. Okay. And hopefully you see the start of this parabola shape, right? Looks like the turning point this time, the point at the bottom of the parabola is this 0, 1, right? This solution here. So, it's not the third one like it was in the last 2 examples, right? The last 2 examples, it was my third point when I plugged in negative 2 to 2. Here it's the fourth point. That looks like it's this turning point. So let me plot some other ones. So let's say I were to plug in 3 for y. Remember, I was plugging in values for y, not x. So if I plugged in 3 for y, well, 3 minus 1 is 2. 2 squared is 4. I'd get 4 for x. So 4 for x, which I have here, and then 3 for y. That point. If I plug in 4 for y, 4 minus 1 is 3. 3 squared is 9. I'd get 9 for x, which I have out here. 9 for x would give me 4 for y. At that point there, and now hopefully you can see the more of the parabola shape coming in. All right, and I'll draw that again. So again, it's not pointy down here; it's more curvy, right, like that. And then going through these other points and continuing that way forever, a little arrow, and going through these points and continuing that way forever as well, a little arrow. Another nice little parabola shape. Wonderful. Alright, so again, this is it. This is the point plotting method, right? Just several examples. You got a few lines, a couple lines, a few parabolas. Just again, plot enough points, find enough solutions to see a pattern forming, and then fill in the rest where you think the rest of that pattern is, and you should have your complete graph. And as I mentioned earlier, if you can solve for a variable pretty easily, do that. It'll make it that much easier. Your tables will be cleaner, and the points will be easier to find. If not, you can always leave an equation the way it is and find solutions that way as well. You saw me do that with my second example in this video, that 2x plus 3y equals 8 line. Alright, and as always at the end of these I like to say, try your best, do the best you can to understand and get the material on your own before you go looking for help, because I find people tend to remember things better. It tends to stick with them better if they learn it on their own, if they took the time and the effort to really get it to stick on their own. So read the material, read the author's examples, try to understand them, or sometimes even try to work out the examples before you even read how the author did it, and see if you can learn from mistakes there. Work on practice problems, look up answers so you can check yourself. But don't give up after the first try. If after several attempts at a problem you're still getting stuck, go back and read through the material again, maybe even a third time. Right? Perhaps the second or third read through you'll see something or something will click that didn't the first time through, and it'll make the problems that much easier. But if not, if after several read-throughs of the material and several attempts at problems you're still not getting it, still not clicking, then it is not a sign of weakness whatsoever to go asking for help, go looking for help. That is what other people are out there for. So ask a teacher, a tutor, a friend of yours, someone in your class, if you're in a class, who knows the material well and is willing to help. Look for supplemental materials online. Look for videos to supplement your instruction, like this one or other ones out there about the topic that are, I'm sure, better than this one. I promise you they're out there. You can find them. There's videos on everything. You'll find them, trust me. And just keep at it. Right? Just stay persistent. Keep practicing. Don't give up. And try to have a positive attitude. Don't automatically assume you're going to hate something, but just because you've hated it your whole life. You just I hate math. I hate math. I hate math. Well, guess if you keep that mindset, you're probably just going to continue to hate it, and nothing's going to change. So just try to go into these things with an open mind, thinking, I'm going to enjoy learning today. I'm going to take something out of this. I'm going to enjoy myself. It's going to be good. Going to have fun, and it'll be amazing. You might surprise yourself with the difference that can make. So keep at it, keep practicing, try to have fun with things, and thanks for watching.